Every day, hundreds of natural events happen all around the globe. Fires, hurricanes, thunderstorms, earthquakes. These all can be seen from space. Reporting on all these events is a time-costly task. We asked, could we leverage a new natural language processing techniques to provide NASA authors a tool to help facilitate the reporting of natural hazards and phenomena? This project is challenging, but the success will have scientific and societal impact, helping NASA's Earth Observatory inform the science-attentive public about natural events in a much shorter time frame. It is with this context, I'm very pleased to introduce the team behind automated reporting.
Hello, everyone. This is Vasiliki from the Automated Reporting team, and I'm glad to kick off the presentation of our project for FDL 2021. Our research team is composed by Fexen, Vishwas, Noah, and myself, and we are fortunate to be advised by great faculty, Piotr, Kevin, Deepthi, Kumar, Frank, and Raul. Our home Earth suffers from extreme events every day as a result of climate change. Wildfires in Turkey, hurricanes in southern United States, drought in South America, and extreme floods in Central Europe are only a few examples of such events. As time goes by, such events are going to intensify, which means that we need to take action. The need to report, educate, and raise awareness about such events is even more urgent. NASA Earth Observatory serves these aforementioned rainfall needs, as it provides information about natural hazards, disasters, and events of natural significance. Here is an example of an article in NASA Earth Observatory website that conveys important information about the destructive Hurricane Doria. To sum up, all around the Earth can occur every day numerous critical events, from east to west, from floods in central China and Europe, droughts in South America, Brazil, hurricanes in southeastern United States, and wildfires in California. The more the events pile up, the more urgent is the need to assist writers and the reporting procedure. And here is where the automated reporting team of FDL 2021 has joined forces. And with that being said, I'm going to hand it over to my fellow researcher, Fexen, to talk about the data and our challenge.
Thank you, Vasiliki. That's right. There are so many events to write about. First, when a phenomenon is detected from the satellite images, it goes to NASA EONet, where it contains the set of metadata related to the event, basic important information such as location coordinates, date of the event, and sensors used to capture the image. On the right is the corresponding example narrative from NASA Earth Observatory, which contains the metadata information. Here's a zoom in on one of the paragraphs in the story. In our NASA Earth Observatory dataset, the average number of words in the relevant metadata for a story is around 28, while in a piece of narrative, the average number of words is about 250. So one can imagine the approximate number of words in context that we will need to automatically build a story. And it's not just any story that we want to generate, but a story which will be specific to the respective event. And that is a challenge. Now I'll hand it over to Noah to talk about our machine learning pipeline.
Thank you, Fexen. So natural language processing, generally speaking, the application of machine learning to human language has experienced significant growth over the past decade. One especially big reason for why is the introduction of the transformer. This specialized deep learning architecture is known for something called the attention mechanism, which allows for fast and effective processing of sequential data like text. These transformers have been especially capable as something called language models. You've probably encountered a language model before. You can use them to translate a sentence, predict what you want to say in a message, filter the sentiment of comments or reviews, or summarize a paragraph into a single sentence. In our case, we are pushing this kind of model to the limit by synthesizing reports about natural events. To undergo this task, we use and modify recently published language models. These models are primed using text found on the internet, like Wikipedia, whereas here we're only interested on text associated with Earth science. The outcome of this work is our model dubbed the Earth Science Transformer, ESTR for short, which allows for the ability to generate and more generally work with Earth science-focused text. But we don't stop there. Utilizing the versatility of language models, there are many applications for ours. We show it possible to train ESTR using automatically extracted conditions from NASA Earth Observatory and use those conditions as inputs to generate the kind of narratives we're looking for. To further refine these reports, something we have proven to be useful as well is to continue training on a particular event type, giving the model even more information about such phenomena. In this way, if you wanted to generate a story about wildfires and pay special attention to that, this approach will do just that. To demonstrate these results, I'll now hand it over to Vishvesh.
Thank you, Noah. So let's now see some results. We will see from the example that how our model has generated the acceptable result for the event that happened recently. The given example is about the wildfire that happened in California. As you can see on the left is our model input. We pass the title with its metadata and summary along with the keyword extracted using the name entity recognition. All the texts are then passed to the Earth Science Transformer model as an input, and the model generates the narrative. It's amazing to see how the generated output narrates the smoke and a fire event that happened in California. Highlighted in the bold are the date and the location. For example, August 20 and Sacramento Valley, which are correctly captured by the model. It is also interesting to see that the model can understand the event type, which is fire and smoke. Moreover, it also talks specifically about the sensor name like MODIS and NOAA satellite by which the data was acquired. So now, the question is, how does the system works in deployment? Well, we have designed a system where first the writer will insert the key information like metadata, story title, and summary by either inserting manually or the system will fetch all the information from references. Following that, as you can see in the output, our model generates the different narrative from the various models. In the end, the writer will select the most likely one or the best narrative of their choice. In addition to that, they can also write their own paragraph and manually input the new narrative. We collect the feedback for the given input and whichever result was selected to do the further improvement of our model performance and conduct the analysis. As a part of our contributions, first of all, we will provide a collection of machine learning models to NASA for a narrative generation. Along with that, we also plan to release our model open source via Hugging Face so that the public can directly use them. Secondly, we will provide a web application as well as APIs for inference and writing narratives. Moreover, we will facilitate the tool for a NASA, which will assist writer and at the same time collect the feedback and improve the models over time. We also believe that our models can be used in a downstream task like classification. For example, to classify a specific natural event in a given story. And hence, we will release the benchmarking dataset with a set task for the NLP community to open the problem to public. And last but not least, the team is planning to put all the resources as a one package and release the PyESTR, our PyTorch-based framework with a proposed multi-data source training strategy for performing training as well as evaluation techniques for machine learning models for narrative writing. And with that said, I will wrap up our presentation by saying thank you to FDL and NASA for providing the opportunity to work on this project. And on behalf of the entire Automated Reporting team, we thank everyone for joining us today.
Great. Really well done, Automated Reporting team. And I'm going to go ahead and bring back up Bill and our panel for discussion about your work.
That's great. Well, another wonderful presentation and amazing work. And, you know, I hold NASA on a very, very high standard when it comes to developing acronyms. They're, you know, among the best of the best, in addition to their many other attributes. But I think the FDL teams are giving them a run for their money with things like ESTR and PyESTR. So this is great. So joining Scott and I for this panel discussion, we have Manil Maskey, who is at NASA headquarters and is a manager of Earth Science Data Systems. And also with us is Deepthi Karkata, Deep Learning Software Engineer at Intel. So hello, Deepthi and Manil, good to see you. And Manil, let's start with you and get your impressions on this work and its relevance to what you're doing in Earth Science at NASA, particularly in terms of how to manage all of the image data that's coming in constantly from NASA and other assets.
Yeah, this is very exciting. AI will be soon be able to tell stories, right? Specifically science stories. That's very exciting to us. So this, I want to give a little bit of context. Last year we ran a challenge called Knowledge Discovery Framework that looked into using AI to identify these events using our image archives, right? So we thought, hey, why not, once we detect those events, why not describe them, right? So that was the natural follow-on to that. And I think from what I see, great progress being made in 8 weeks, and we have a practical use for this. Not only just automating, but consistency, right? Hopefully, when AI is writing these stories, it's very consistent, right? It's not, let's say, I'm not saying it's by stories, but when AI writes, I think they'll be more consistent. And this is just the Earth Science example. There are events everywhere, right? In all of the science domain. I think this is naturally extendable to other domains as well. And in terms of NASA, I think we've noticed that most of the researchers, especially early career researchers, right? They go into websites to figure out what they want to work on research-wise, and they naturally go and study some event and focus on those events, right? So this really provides this efficient way of cataloging these events and describing them, and hopefully provide more resources for those early career researchers.
Yeah, absolutely. Definitely. We talk about this a lot in the program. It's not as though AI and machine learning are replacing humans or human activity in the sciences, but rather, enhancing them and facilitating even greater insight. So that's really important. And Deepthi, what from your perspective, you were involved also working with the team and supporting their efforts. What were some of the big challenges you had to overcome, or that really presented puzzles in bringing this team together, or not the team, but rather bringing these results together that are so impressive?
Yeah, definitely. So reporting of natural events is highly impactful in itself, because it's bringing awareness about these natural events all over the world. But as you can imagine, automated reporting of these events is challenging in itself. Challenging because it has to infuse domain-specific information with general language to create fluent and easy to understand stories and narratives. So that's exactly what these researchers have done. So they've gone and gathered and accumulated data from different sources that are domain specific, and put them together and build pipelines for training and evaluations of these models, and also work on robust evaluations of these models, I should say. So, and also a part of these resources are planned to be open sourced, so that other researchers and the community can build on top of this work. So it's a challenging thing, but it's commendable what the researchers have been able to do over the last 8 weeks. And it's creating pathways for like the community and other researchers to build on top of this work. So
yeah, absolutely. It's amazing. I mean, the idea that an algorithm could look at an image, have access to the metadata, and then write a story about it. Scott, is NLP going to change the world? Where are we going here?
Bill, it's when I talk to my friends who are doing research in the climate crisis, and they can looking at the fires, the floods, the drought, everything else, they're excited about figuring out how to really help us all. Yeah. Not one of them has ever said, what I love about this? I love writing reports. It's my favorite thing to do. And so this, to me, it's fundamental. You're now just, I love this team because you've taken one of the most advanced things in AI today, which is NLP and Hugging Face and these GPT transformers. And you're saying, let's get rid of the tedium. Let's go take this technique and then help you write the report so you can do great science. I'll write the report for you. You can edit it. But that, I think what you're doing is you're uncorking the ability to accelerate science. And I think it's fantastic. And I think we're going to see this, Bill. We're seeing it now today with like Gmail. You can autocomplete a few words.
Right.
We're not that far off where it's going to write a draft for you. And I love the idea of applying this to science, especially on the climate.
You know, I love the fact that I don't have to type as many letters into my text messages as I used to, right? Because it predicts what I want to say next.
Yes, exactly.
Right.
And for scientific writing, this is just, it's a great idea. And kudos to the team.
It's brilliant. Well, congratulations to the team, and thanks again to our partners on that work. It's really terrific. And you know, so here we have an example of machines aiding in the storytelling and description of scientific data, of scientific imagery data in this particular case.